Okay, so number 14, according to Google, and Google is always right, right? The half-life of carbon-14 is 5,730 years. See the little screenshot below. So I actually looked it up for you, and then we found out that that's what we're talking about here. So assuming this is correct here, let's come up with an exponential decay model for carbon-14. So we're going to start by saying, okay, A has to be initial amount e to the kt. All right, so and what we want to do is the half-life is 5,730 years. So that means whatever the initial amount is, half of that becomes our new A. So A initial over 2 equals A initial e to the k, and then time was 5,730 years. So that's the setup that we're going to do, and we're looking for k. Once we have it, then we can go back and plug it back in. Okay, so here's what we end up having. A naught over 2 equals A naught, so this is going to be 1/2 is now equal to e to the 5,730k. If you just multiply both sides by 2 and then divide by A naught, your initial amount goes away. So now I'll come down over here for you. So the natural log of both sides here, natural log of 1/2 is now equal to the natural log of e to the 5,730k. Well, this part can now go down in front. That's the power rule. So we have natural log of 1/2 is equal to 5,730k times the natural log of e. But we all know the natural log of e is just the number 1. So going over here now, we have that k is approximately equal to the natural log of 1/2 divided by 5,730. When you plug this into your calculator, you get approximately negative 0.000121. You might get negative 1.21 times 10 to the negative 4, and that translates to that in your calculator. That's a very, very, very small number. Okay, so the model that we're looking for when we go back and plug this all in would be this. The amount left over is the initial amount times e to the negative 0.000121t, and that is our exponential decay model for 14a.